In this video, we'll review system of equations and we will solve by graphing. Okay, so we will use lots of graphings and we will find point of intersections and we will read ordered pairs for solutions. So let's start with the number one. Number one, do we have ordered pairs? Okay, what? These are the system of equations, and we have blue line and green line. And we see ordered pairs at that point of intersection, that is x coordinate and y coordinate. Since we have two variables, we need to list two answers, okay? What is x, what is y? Easier way to list two things is not like that, right? X is 3, y is 4. It's okay, but it's easier to write as an ordered pair. Make sense? Number two, how many solutions do we have? Two pairs, right? 2 points, point of intersection. Number three, we have exponential function and linear function. It's okay to have two different equations like that, okay? Where do they meet? That is ordered pair here and there. We have 2 points of intersection, so we have answers like that, okay? So let's write answers. -1, comma, -2. And another one is 2 and 1. Okay, here same thing. -0, comma, -1. Another one is 2 and 2. Next question, which of the system of equations below have a solution of -3 and 2? You may see this kind of a problem on multiple choices a lot. And we want to check system of equations. It is working with this solution. And we need to check both of them. If both of them is working, we will say, yes, it is a solution for the system. If one of them is not satisfying with this, and we will say, no, it is not a solution for the system. Okay, so let's plug in. So let's check. 2 equals to, I'm plugging -3 and 2 in the ordered pair, okay? Don't put first number, always first number. It's not. This is x coordinate and this is y coordinate. So use the corresponding number. 2 times -3 plus 8. Is this true? So let's check left-hand side, right-hand side. Right-hand side, -6 plus 8, so that's true. So first one, working, okay. Next one, let's plug number. 3 times, x is -3 and y is 2. So let's check it makes -5 on the right-hand side or not, okay? So check it, and if it is working, left and right hand side, yes. 2 equations are satisfying with this solution. So this solution is the system, satisfying the system. So yes, this is the solution of the system. Okay, now let's look at number 7, and we avoid using a calculator, and we are not just copying calculator work on the page, okay? So let's see. I'm going to graph this with pink color. So let's go to last number, which is y-intercept. Y-intercept is the number on the y-axis. So go to -4. Plot the point. And slope is 1/2. Slope is 1/2. That means rise over run, right? Rise over run. 1 up, 2 to the right. That is the slope. So from the y-intercept, we move that direction. 1 up, 2 to the right. Repeat. 1 up, 2 to the right. Repeat. 1 up, 2 to the right. So this is the equation of the line. Okay, and the other words, the other ends, we can go down 1, 2 to the left, so we can connect them. Use a ruler if you can, okay? All right, that is one graph. This is slope-intercept form, so it is easy to graph it because we can see slope and y-intercept quickly. It was okay. But next one is not slope-intercept form. This is standard form. So I'd like to change the form so I can graph quickly, okay? So let's do a little bit of algebra. How do I change the form to slope-intercept form? I need to remove this term, right? So let's move the term to x by changing sign. So negative 2x, we subtract negative 2x from both sides, plus 1. So what is the slope? Slope is negative 2. What is y-intercept? 1. So we go to y-intercept at 1. And then let's go to slope. Negative 2 means negative 2 over 1. Or you can take care of this negative in the denominator. Either way, fine, okay? One of the numerator or denominator has negative, that will be negative. So let's go this way. 2 down, 1 to the right. 2 down, 1 to the right. Repeat, 2 down, 1 to the right. Oh, that's overlapping. What is that? That is the point of intersection, so that will be the solution. Let's continue do it. 2 down, and then 1 to the right, 2 down, 1 to the right. And the other way, 2 up, 1 to the left, so you can form a straight line on the same direction, okay? So this is the graph of that, and then let's find the solution. This is the ordered pair, right? So let's read that ordered pair. It's at 2, negative 3. So x value is 2 and y value is negative 3 from the graph. Okay, now let's look at next group of the questions. All right, let's see. Number 9, 10, 11. Each system of equation is shown in graph. How many solutions does each system have? So let's look at the first one. Where do they meet? Oh, they do not meet at all, right? What is the number of the solutions? Nothing. So there is no solution. So we have 0 solution, right? You can write no solution, or you can just put 0. That's fine. Number 10, 2 lines meet at one location. How many solutions do we have? 1 solution, right? 11, 2 lines are overlapped because equations are same, okay? How many solutions do we have? There are infinitely many is the key, okay? How many? Many. Can I repeat? Many forever? Yeah, that's infinitely many, okay? Many solutions. So that's how we describe the number of the solutions. And I want you to remember the terminologies. Do you remember independent system, dependent system? No, we haven't heard about it. Okay, and I always say this is independent system. How many solutions? 1 solution. And then we say independent system, okay? That is the terminology going with it. So think about July 4th, Independence Day. How many days are Independence Day in a year? Only once, right? So think about some connections like that. And this one has 2 lines overlapped, and I always go with this is marriage, okay? And husband and wife. Okay, this one, husband and wife, and one is called dependent of the other, okay? So we use dependent system for this situation. So connect with something so you don't get confused. Dependent system. Dependent system, okay? And there is a terminology for no solution. And no solution, and we say inconsistent. So what is the meaning of consistent then? Consistent means there is a solution. So 2 cases all together, there is a solution that's called consistent system. So these are the terminology for describing the system, and we need to make sure you understand that, okay? So inconsistent means no solution. And I always say, you don't do homework at all, no homework, And homework is not consistent like that, inconsistent. Okay, so make connections with the real life so you can identify the systems correctly. Consistent means there is a solution. Inconsistent means there is no solution. If we have only one solution, we say it is consistent and independent. If we have so many solutions, we say that's dependent system. Okay?